An ordinary guy who got up and said these strange things. Fredkin, at that time, I think, was from MIT, very distinguished physicist. Then went on, I think it was next was Boston University. Then he went on to Carnegie Mellon. He's had a very distinguished career. At MIT, there's a prize called the Fredkin Prize that has to do with Fredkin. So this is not a lightweight renegade physicist like me. This is a big heavy hitter here, Edward Fredkin. And that was in 1992. Well, what happened since 1992? The idea has spread, but it's still out of the mainstream because people don't know what to do with it. Same thing with Einstein's problem. You know, you get to a point and it's like, well, okay, that's what the data says. Now, he didn't just make this up that this was his opinion. He presented this, you know, in a physics forum. This is where the data led him. This was the only logical conclusion he could come to. Again, sort of like Bob, you know, he didn't want to come to this conclusion. You know, it's not like this was something that he thought was neat. This was something he thought was nuts. But that's where the data went, and a good scientist reports what the data says. So he did that. What he said about, you know, the computation, you know, the simulation, said, well, if it's simulation, he said there's a problem there. A simulation doesn't compute itself. A simulation has to be computed someplace else. So they said, well, Dr. Fredkin, you know, who's computing this simulation that we are? And he said he had no idea. He said that it's in other. And other was outside of physical reality, because obviously the physical reality is the simulation. It's not just Earth, it's the whole universe. So he said it has to be in other. Well, if it's not physical, what is it? Non-physical. We would call not physical, non-physical. But physicists never use the word non-physical. That's not an acceptable word to use. Squirrely people and, you know, New Age people use that kind of word. They stay away from it. So they just say it's not physical. It's other than physical. Now, Nick Bostrom, he's now at Oxford. He is a guy that has a degree, both an advanced degree in both philosophy and in physics. He's worked both sides of that field. He's actually head of a department at Oxford. He wrote a paper entitled, "Are You Living in a Computer Simulation?" And he asked that question after some study. You know, he asked, is it impossible? Is it impossible that we actually could be living in a computer simulation? So after some study, he decided that it was impossible to say that it was impossible. So then he said, well, if it's not impossible, then, you know, is it unlikely? How likely is it? Well, after studying that question, he came back and said, well, it's unlikely that it's unlikely. The result was, you know, that it's almost certain then that, you know, we're all living in a simulation. So again, this is a fairly heavyweight, well-recognized scientist. Last of all, and most current, you know, we're coming up in time from '92. This Bostrom thing was probably in about 2000. And now Brian Whitworth just about a year and a half ago wrote a paper that said the physical world is a virtual reality. And what Brian Whitworth did, and he's actually a mathematician, works in advanced digital sciences in New Zealand. And he said, well, you know, we have this digital physics movement been going on now for a decade or two. He said, let's just see whether they have, you know, good ideas or not. He says, I'm just going to assume that reality is virtual, that it is a simulation, a digital simulation. And I'm going to see how well that answers the questions. You know, how does that answer the facts we know about physical reality, the standard physics things? And then you take the assumption, the other assumption is that physical reality just is, you know. That's what physicists now start with. What's physical reality? Where did it come from? It just is. It exists because it exists. Well, anybody else would call that mysticism, right? That's the fundamental basis of where physics is. So those are the two theories, that it's a simulation and it just is. He decided, after doing his research, a nice paper, it's about 15 pages long or so, is that the concept of reality being virtual and digital answers the mail better than the current basis for physics. that he got more of the outstanding questions answered. Now, he also said, here's a few problems with it. And then he took the other side and he said, here's what we can answer, and here are the problems with it. And the virtual reality, as the fundamental assumption, turned out to answer a lot more questions with a lot fewer problems. And his result of that paper was, physicists, wake up. You know, this is a better theory. By your own standards, this does a better job of explaining physics than the one you've got. Okay, so next. Okay, so we see that science is basically poking at this thing, but just like Einstein, they get to this point and it's like, well, okay, if we make that assumption, now what? You know, now what do we do? And the answer is, you know, they don't know. So let's go back to the old assumption because we know what to do with that. You know, so they don't like it because they don't really know the next step, what to do with it. Well, the reason that they don't is because the next step is not an objective step. The next step is not a measurable step. And what they do is objective and measurable. So the next step, you have to understand that consciousness is the fundamental reality. And that's back where Einstein left off, right? That seems to be the problem. Well, now, if you could study consciousness like you could study a bug or like you could study a rock, they'd be all for it. But you can't study consciousness like that. You don't learn a whole lot about consciousness by studying somebody else's consciousness. That's not what consciousness is. It's not objective. And if you keep trying to make it objective, you end up with an empty bag. You know, it doesn't have any answers in it. The only way to study consciousness is in here. It has to be subjective. It has to be personal. It has to be inside. And science doesn't go there. So they're up against the same wall that Einstein ran up against, you know, 60 years ago. And that is, it has something to do with consciousness, but we don't go there because that's not scientific. But yet science keeps pointing in that direction. It says, hey, this is the answer, but it's not an answer that science can deal with. So that's kind of the sticking point. All right, consciousness is the fundamental reality. The large consciousness reality is a digital system. At the most fundamental level, consciousness is information. The most fundamental level, information is bits. And at the most fundamental level, bits are binary. Now, that's not to say that reality has to be based on binary considerations or anything like that. That's not the case, but we're just reducing all of these things to the simplest form in order to talk about them. So if consciousness then turns into a non-physical information system, a digital, non-physical, digital information system. Now that sounds a little nuts, doesn't it? Consciousness, you know, and we're a simulation. Consciousness is a non-physical digital information system, but the model works. Not only does the model work for science and answer their questions and derive quantum mechanics, but it also works to explain all of the Eastern philosophy, theology, paranormal, everything else drops out of this with this model. You can explain everything, thus a theory of everything. As I said, it's non-physical, it's subjective. Consciousness is non-physical and subjective. This is an important thing. Information, you know, we say consciousness, it's information. Information is the meaning, it's the content, it's the message. Information is not the media or the code symbols. Okay, if you look at a book, the paper, the book is the media. The little ink squiggles on the pages are the code symbols. That's not information. That's a way to store information. It's a way to transmit information, but it's not information. Information is the meaning, the significance. Well, how do you get information? Consciousness has to look at it. Only the consciousness can get the information from the book. The consciousness can interpret the code signals that are stored on the paper and get the meaning, get the concept. Without consciousness, there is no information. Now there's the media, it's still there. The code symbols are still there, but it takes consciousness to find the information. And another way to look at this is the code symbols in the media are physical, are they not? You can put a book in a bottle, book's a physical thing. But the information, the meaning, where's that? Can you put the meaning in a bottle? Can you weigh it? Can you measure it? Can you do anything that you normally do with physical things? No. So what is it? It's non-physical. Okay? But yet you can break information down into pieces and parts, code, words and letters, digits, bits. Okay? So now it starts to pull together a little bit. Information is non-physical. Consciousness is an information system. Another way to look at this is that, okay, we're conscious and we're in this reality frame and we're taking in data, and this data is our experience, right? Well, what is this data that we're seeing? Okay, you're looking at me, and let's just look at the visual and of course the audio part. That's most of it here, is visual and audio. What is this? It's data. It's photons, these little particle of light, right, that don't exist until you measure them. They're bouncing off of me, they're reflecting, and they go into your eye. Okay? Now, the photons are digital themselves. They're not continuous. They're little bits of information. Once they get into your eye and get onto your retina, what are they? They're little electrical impulses. They're digital. Then they get into your brain, and what are they? They're neurons. Well, what's that? Little discrete specks, right? And those little discrete neurons get into patterns, and patterns of patterns, and that turns into your awareness. That gets interpreted by your consciousness. Okay? So you see, it's all digital. It's all information. So me standing up here talking to you is just digital information that you're processing. You're picking up with your sensors, your eyes and your ears, the sound waves. It's digital energy. The neurons, the impulses in your brain, electrical impulses, it's all discrete digital signals. So your experience is just information. All this photons, all this energy and things that are impinging on it that your sensors are picking up, it's just information. Now, let's say that I can reproduce all this information that's impinging on your senses. You know, I've got a machine that can do that. Reproduce it precisely. And then I'm going to take you and I'm going to put you in a very dark, deep hole in an isolation chamber where you have absolutely no light, no sound, no sense of feeling, nothing. You're just, all of your senses are turned off there because it's such a dark, deep hole. Temperature of your body, you know, you don't have, you're suspended anti-gravity machine or something, so you don't feel weight. Okay, you're just consciousness. But now I can stimulate digitally your nerves, your optic nerve and your audio nerve, exactly the way I'm doing it now. What would you hear and see? You'd see exactly what you're hearing and seeing now. What would be the difference? How could you tell that you weren't here, that you were in this deep, dark hole in an isolation chamber? What little fact would you be able, how could you tell that? You couldn't. There's no way. So then you ask, what's the difference? There is no difference. You see, there is no difference. It's just data. So what are you then? You're a consciousness. You are a consciousness receiving a digital stream of data. And what is all of this? This is how you interpret that data. That's a different picture, isn't it? That's how you interpret this data. Okay, an information system, you know, a digital information system is represented by organized bits. Okay, now we're going to talk about entropy for a second, because this is kind of integral. Now, if you were a scientist and into information theory, this would all be old hat to you. Information has entropy. Information has to be organized. Okay, if you just take a bunch of letters from the alphabet and throw them together, you don't have any information from that. They have to be organized in a particular pattern of code so that you can interpret them, and then you get information. So if everything is random, there's no information. Now in EE and in information science, they talk about signal and noise. You know, noise is the randomness, signal is the information. This is the same sort of thing. So in order to have information, you have to have organization. Things have to be organized in a very particular way that you can interpret that organization. Okay, now a measure of organization is called entropy. That's a term that's been around for 100 years at least. Particularly came up in the second law of thermodynamics, which came to the unsettling conclusion that the entropy of the universe must always increase. Now, entropy is a measure of disorder, not really a measure of order. So what it says is that eventually the universe will be reduced to a uniform cloud of elementary particles, basically. You know, but it'll take a long time, so don't worry. You don't have to go to you don't have to go get the extra, milk and bread. You get ready for it. It's a long time, but that's the second law of thermodynamics. It basically says that all systems run out of energy. Energy gets consumed, you run out of energy. Basically, a system, decays. Okay, now, so that's where entropy came from, a measure of disorder. In information theory, the amount of information, the amount of content you have is dependent on the amount of organization that you have. Okay, now let me give you an example of entropy. If you'd had anything, we take this computer. If you had this laptop computer sitting here and you disassembled it and took it all apart, every component, every nut, bolt, washer, electronic device, diode, chip, everything, and you took all the parts apart, so that all you had was single parts, and you put them in a pile here on the floor, you would have just increased the entropy of that system. The computer's the system. Okay? With all the parts just randomly organized, well, not organized at all, just thrown in a pile, what can it do? Nothing. It's not even a good paperweight. It can't accomplish any of the things that it can accomplish when it has low entropy, and all those parts are just in the right configuration so that the way they interact with each other is just so. So that's an idea of entropy. Okay, so a computer on the floor and parts is a very high entropy. A computer put together like that takes that same system, again, the system being the computer, makes it a low entropy system, and now it can do, there's two things that it can do that it couldn't do as a pile of parts. One is that it has the power to change things. It's got a certain amount of power. It can change its screen. It can give you different things. It can do things. Okay, that's one thing it has. Okay, that now that it's organized. So it increases the ability of the computer to do work. So it's organized, two things. It's organized, and it can now do work that it can't do as a bunch of parts. Well, your information is the same way. Okay, so if you have a large information system, that system evolves, and that's another key word here, evolves. All systems, all complex, large complex systems that can change themselves, evolve. How do they evolve? They evolve by lowering their entropy. So take any system. Take technology development as a system. It evolves by lowering its entropy. In other words, it evolves by taking what it knows now and organizing things better. More connections, figuring out more ways that things can work together and fit together and connect, things that can, that you can use. We talk about our biological evolution. Biological evolution has the criteria of survival and procreation. That's the criteria that drive it. Okay? In an information system, the criteria that drives evolution is entropy reduction, getting the noise out of the bits, configuring the bits in a way that produces information. Okay? Produces content, produces meaning, produces significance. All right. Consciousness is a self-aware, self-modifying system evolving toward lower entropy states. Okay. Now systems have to evolve. They actually only have three choices. If you look at it logically, they can evolve, which means lower their entropy. They can devolve, which means increasing their entropy, or they can remain the same. But there's really only two choices, because in any large, complex, self-changing system, change happens. Staying the same is not an option. It's not a stable option. You can sort of stay the same for a while, but eventually you're either going to grow or you're going to die. Those are the only two choices. So given those two choices, evolve or de-evolve, basically grow or dissipate, devolve, then obviously any system that has any that's self-changing is going to evolve. So evolution is a fundamental aspect of large complex systems. Think of the monetary system. Think of political systems. Think of any large complex self-changing system, and you see it fits the same thing. They have to evolve by decreasing their entropy, becoming more useful, gaining power, being able to do things better. Okay, next. Okay, so here are the attributes of consciousness. Okay, I think we've gone over most of this. Individual consciousness. Individual consciousness now, we're talking about the big conscious system is a digital information system. Your own personal consciousness is just a piece of that, a subset of that same system. So we are all connected. We're all part of the same thing. We're all part of this one consciousness system, but we're a subset of that. So individual consciousness, evolves toward lower entropy and higher quality, more spiritual states. Okay, love is the nature of a low entropy consciousness. And I just defined a bunch of words there and terms. So consciousness, as it evolves to lower entropy, evolves toward love. A very low entropy consciousness is love. Not that it acts like love or it acts loving, it is love. That's the definition of love. It's a very low entropy consciousness. Isn't that interesting? Love is a measurable quantity in terms of entropy, a term of physics. Now we can rephrase that and say, well, the consciousness is evolving towards states of higher quality, same thing. Or we can say that the consciousness is evolving spiritually, same thing. So all these are just different words from a different frame of reference that are all saying the same thing. Okay, now a self-changing consciousness system, it's self-aware, it learns, it's alive. What does it do? What are the attributes? It has input, okay, that's called experience. Input, that's all those digital data that's going into your senses. That's the input, right, for your individual consciousness right now in this reality frame. Okay, or if you think of it in the bigger picture, it's that data stream that's going into that conscious mind that makes you interpret it as this physical reality. Another way of looking at that is this reality that you're in is a virtual reality trainer. If any of you are pilots, you've gotten in link trainers and you know that you sit in there and it's just like being in an airplane. It even crashes like an airplane, it's just nobody dies. They use those to train pilots. It's a virtual reality trainer. You can play video games now, World of Warcraft and things like that are virtual realities. They're not trainers, but they're virtual realities that you can get into and play. It's that same idea. Okay, so you have to have input. That's your experience. That input then, you have to have processing. Okay, and that's so you can compare and assess that experience. The experience by itself isn't helpful unless you have a way to operate on that experience. Okay, you need to have purpose, because the purpose lets you take that experience and decide whether it's meeting your purpose or not. That's the difference between evolution and de-evolution. That's the difference between good and bad. If it's meeting your purpose, it's good and you do more of that. And if it's not meeting your purpose, that's bad and you do less of that. So you have to have input, experience. You have to be able to process that experience and compare. You need a purpose to tell whether the experience is good or bad. And then you have to be able to self-modify, which means you go back up here and do what's necessary to change the input. Okay, so that's, you know, so if your input is that you put your hand on something hot, right, that gives you an experience. You process that and say, not good, you know, increasing entropy here, you know, my cells are burning. Then you say, I'm going to modify that, so you pull your hand away, right? That's consciousness. It has to work in the cycle. Well, what else does this sound like? Input, processing, purpose, self-modifying. It starts to sound a little bit like your desktop, doesn't it? Your desktop has input. It does processing. You give it the purpose. You know, you're the one that tells it what you want it to do. You know, load that CD or whatever. You give it a purpose in a particular task, and it goes, does it. It changes things in order to meet that purpose. But your desktop's not conscious. Your desktop is not conscious because its purpose is very, very limited. A purpose of a complex, self-changing system is this lower the entropy. The computer's not trying to lower the entropy of its system. It's not aware yet. But does that mean that a computer will never be aware? No. All you have to do is give it enough choice that it can choose what actions to do and give it a purpose for doing that, and you will evolve consciousness in that computer. Now, you don't have to program it in. Consciousness just appears where you give it the necessary components required to be. And it will be there. So it's not a hard thing that you have to do. You just have to give it the platform in which to exist. Now, that consciousness, it's not going to be a talking head, right, that'll discuss philosophy with you. It may be at the same level of consciousness as a bumblebee. You know, bumblebees are conscious too. So are clams. You know, so just because you're conscious doesn't mean that, you know, you're